So hopefully this concept of pointers is starting to click with everybody. It's not an easy concept and it takes a while for it to click in usually. So now I'm going to cover the last part of Chapter 6. This is one of the optional sections in Chapter 6. It's called it's about dynamic memory allocation, which you have to you can only do it when you use pointers. So some of the material I'm going to take to talk about this concept I'm getting out of a book called Beginning C, 5th edition by Ivor Horton. So I'm going to take a little bit of his material to help explain it, because your book actually has a pretty short section on dynamic memory allocation. So it allows memory to be allocated or assigned when the program is executing and not when the program is compiling. So normally you compile your program and you've set up some arrays in your program, for example, and that memory is allocated when you compile it, and as you start to execute it, then it'll be set up for you as it executes. But you cannot change the size, so any arrays that you have set up in your program, that memory will get allocated by your array setup, and you cannot change the size of your arrays. So dynamic memory allocation allows you to change the size of your memory space as needed when the program executes. An example might be, dynamic memory allocation is used in all production programs. That means professional programs are using it. They are not reserving giant spaces of memory and then only using little pieces of it. They are reserving spaces of memory to accommodate what their needs are. So professional programs use it. And then another example would be your email client. So your email has no knowledge of how many emails it's going to receive, nor how much memory is going to be needed. So that's an example of using dynamic memory allocation. And if you consider a simple program that we might write, like averaging test scores, you should have this program be able to run for any number of test scores that you wish to average. So again, that would be an application where you would use dynamic memory allocation. And you can only do it with pointers. So a few other little important terms just to understand the difference. The memory that you allocate during a program is called the heap. And there's another memory area in your program called the stack, and the stack is a memory area that variables and arguments of functions use. And when your function is done being executed, the memory on the stack is released. But when you use dynamic memory allocation and you're using memory in a heap, you have to keep track of it yourself, and you have to allocate the memory and then free the space when you're done with it. And you can get in trouble with your memory if you don't have good housekeeping with your memory. So a little background information there in case you run into these terms elsewhere in your programming career. So on your C reference chart that I gave you, this one that I gave everybody, there is a section in the standard library and standard library functions where it talks about dynamically allocated functions. And here are the functions that we're going to talk about. That's all of them. That's the set of 4 of them that are there. And they are all related to storage allocation and releasing your storage. So I have 2 that allocate storage. That's a make allocation, and this other one, I'm not sure what the C means, but basically you make an allocation, but you also initialize it to zeros. I think it initializes to zeros when I looked at it. So the space that you allocate in memory is not containing junk, but it's been initialized, whereas the make allocation function initialize or reserves the space in memory, but that space could be filled with junk. So and then we can change the size of the memory that we allocate. This is the part that is the most interesting, that instead of, because you can allocate some memory by declaring an array, right? But you can't change the size of it. So this reallocate function allows you to change the size of memory that you're working with. And then when you're done using the memory, you have to free it back up, because you can get in trouble if you don't free it back up. So as I mentioned, you can create arrays, but you can't change them during the program. You cannot change their size during the program. So So let's just show you how to use the functions first. Let's show you how to allocate some memory um, that your program is going to use. So we use the make allocation command. And here's an example of how you would use it. Here's a typical example of how you use it. And it says that I'm going to allocate 100 bytes of memory. Well, if I want to store integers, each integer takes 4 bytes. So I'm really only able to store 25 integers with 100 bytes. So a better way to call this function is to say 25 times size of int. And so that's a better argument, because then it gets exactly the space that you need to store if you want to make space to store 25 integers. Let's talk a little bit more about these pointers. So here's that last command with a better argument, rewritten. So we have a cast operator, int, with a dereferencer star after it. So it converts the address returned to it keeps track. Basically, it's keeping track of the type of information that you are going to be storing in this memory that you've allocated. If you don't do that cast operator, it's not aware of what kind of data is being stored at that memory location, and you can't dereference it in the future. So you want to make sure that because if you want to use your dereferencer and get first piece of data out of memory, you have to know what type of data that is. And if you don't use this cast operator, you won't be able to dereference it and get that piece of data out of the memory location that you've allocated. So, okay, moving on. So you should always release the memory when you're done with it. When it's no longer required, you're getting to the end of your program execution, you should release that memory. You should actually release it and clear it. Now, the memory that you've allocated is on the heap, as we say, and it is automatically released when your program ends, but it is safer to explicitly release it and clear it just as you are when you exit the program. So one of the things that can happen is you can have what's called a memory leak. And this occurs when you make some memory, but you don't retain, your program doesn't keep track of how you get to it. So you are unable to get to that memory and unable to release this memory. So the scary statement, the last statement here, is that this can occur in a loop. And because you are in a loop, you're not releasing the memory when it's no longer required, and your program keeps consuming more and more of the available memory on each loop iteration, and eventually it may occupy it all, or the program will crash. So anyway, always release your memory. Here's how you release your memory. So my earlier example, I had a pointer called p_number, and you just free it, and then it's an even better practice to say that p_number is now null. So you set the pointer to a null after you free it. Okay, so let's show some examples. So here's my first, just a simple example. Notice I had to include the standard lib preprocessor up here, as well as our standard I/O preprocessor. So here I just declare some memory. I allocate some memory with the make allocation, and I want to be able to store 25 integers in there. And just for the fun of it, I print size of allocated memory is however many bytes, and just for the fun of it, I decided to print the location of where the allocated memory is. And so I'm printing the value of p_number. Now remember, p_number is an address, and if I said star p_number, then with the asterisk, right, then the value stored at the address that it's pointing to will be given to you. So anyway, when I run this program, it tells me that I've allocated 100 bytes, and the allocated memory starts at this address. So p_number as some memory location in your computer, and the value of p_number is this address right here. Yes. So a similar function, which is, I'm not sure what this, like I said, I'm not sure what the C stands for. Clear and allocate, I think it might be clear and allocate. So it allocates the memory same as the make allocation does, but it also initializes the memory. So to me this is a better function, and I don't know why I would use the make one, so I would prefer to use the clear and allocate one. So here I took out the original make allocation command and put in inside the clear and make allocation. But it's a little bit different. So in the argument for the make allocation is strictly the number of bytes of memory that you are allocating. And when you use the clear and allocate function, you say that you want to invite, or you want to make space for 25 objects. The object might be an integer, it might be a character, or whatever, and then you have to say the size of the objects. So if I want to make space for 25 ints, I say 25, and then the other half of my other argument is how many bytes that is. So size of int, which would be 4 bytes. And it will, so I want to make 25 memory locations, and each one will takes 4 bytes to store the integer. And then I use the free, after I've allocated that memory, I don't do anything with it because my program right now is boring and a boring illustration. But anyway, I made 100 bytes in memory, I allocated it, and then I turn around and I freed it back up, and then I put the address to null in the pointer. So far not a very exciting program because it doesn't do anything. So I need to give you a better example of how you might use dynamic memory allocation, which that is coming up. So it doesn't really get interesting now until you can actually reallocate your memory. So you can change the size of the memory location that you've reserved for your program, and you can change it while your program is executing, and that therein lies the power. You can't change the size of an array when your program is executing, but you can reallocate memory. So I have an example. There is not a good example in your textbook. There wasn't a good example in my secondary textbook that I was using on these earlier slides, but I did actually find a very nice example on a website called tutorialspoint.com, and this is where I took this example from. And what we're going to do is create a program that stores variable length strings. So the program is going to allocate some memory, put a string in it, and then it's going to try to it's going to use some of our string functions, and it's going to try to concatenate another string into the memory, and but there won't be enough memory set aside, so you won't be able to put the second string into the memory location. So while the program is running, you can reallocate more memory so that there will be enough space for the second string to go in memory. So let me show you this program. So you see, I got it. I stayed up front that I got this from Tutorials Point website. So I do need the standard I/O, and I need standard library, and I need string functions for this program. The first part of the program is I'm just going to declare a character string named name with 100. I can store 100 characters in it. And then I'm creating a pointer called description right here. And then this is, I could get my string from the keyboard, but I'm just, for illustration purposes, I have a string with my name in it, and I'm going to store it. I'm going to copy it into a string with a variable name identifier called name. So name gets Georgianne Provenus. Now I'm going to allocate some memory. I'm going to allocate it dynamically. I use the make allocation one, so I am going to allocate a place to put 30 characters. So 30 times size of character. I think a character is only 8 bytes. Yes, that's true. So I'm actually only reserving 30 times 8 bytes. And since description is a pointer, right? And look where I'm putting it. So this is the beginning address. This is the beginning address of where this 30 bytes 30 bytes is located. So this will be the beginning address of where the 30 bytes is located. Okay, and then this next part is just kind of nice practice. If for some reason I did not successfully set up this memory location, so I didn't get an address for description, so description doesn't have an address in it. If by some chance that didn't happen, and description actually equals null, it didn't get an address, then I'm going to print an error. But chances are I will give description an address. And then I use a string copy function. So I'm taking this string, student is an engineering student, and putting it in the address of description. So this is going in the 30 bytes that I have set aside, and that address is pointed to by description. So at description, I am putting this string in at the address of description. Well, description points to the address. It's a pointer. Oh, sometimes this is confusing to describe. Yep. So you have to think carefully. So I've commented out this statement right now. So the next thing I want to do, I have a standard error thing going again, is I want to put another string. I want to concatenate. So here's a string concatenate function. I want to concatenate the second string into that block of memory called description. Now description is not an array, right? Description is not an array, it's a block of memory that I can point to. So I'm going to put this second statement in there. Now these two statements, student is an engineering student, she is in EE160 class, that's more than 30 characters. The last part of my program says print what's stored in name and print what's at description. So I'm printing the string out that's at description. And then I free description. So let's run this program. I actually already ran it, but I'll run it again. So it says name, okay, and student is an engineering student. And then it says she is, and then it's messed up. Why? Because student is an engineering student, she is in EE160 is bigger than 30 characters, and I only allocated 30 characters of memory in my first allocation. So 30 characters was not enough, but I don't have to start the program over again. I can reallocate and make my memory location pointed to by description. I can make my memory bigger. And so that's what I do. I'm going to take the comment out. I now say the address pointed to by description is now 100 characters. So this is the syntax of how you would do this in your program. So originally description is only 30 characters. It's 30 bytes of memory is allocated for description. Now I did a reallocate statement, and I made it now instead become 100 bytes. But notice I have already put the first statement in description. I put student is an engineering student in that memory location pointed to by description. I put that first string statement into the memory location, and then I reallocated and made the memory location bigger, and then I concatenated the next string into it. So let's save and see that it works. So now I get the whole two strings concatenated together, and then the string my name is stored. Well, the string Georgianne Provenus is stored in a variable called name, which we did at the very beginning. Recall we did that at the very beginning of the program. So I'm going to put this example on Laulima for you so you can also play with it, because it's hard for me to show you the whole piece of code in a YouTube, but I will put the example on Laulima for you so you can also play with it. So I think that ends chapter 6, the parts I'm going to talk about. And we need to move on now. Our next chapter will be about structures.